So two concentric circles have radii of 1 and 4. Okay, so that's basically this circle and the larger one. So meaning that they share the same center. Okay, so and that is given. There are 6 congruent circles from a ring where each of those 6 circles is tangent to the 2 circles adjacent it's shown. So these guys, the other ones, are the congruent as well, and they are tangent to each other. And the 3 lightly shaded circles, which is this one, and that one, is tangent to the larger circle on these like corners. Okay, these are my tangency points. And the other 3, which is these dark ones, are tangent to the other 2 light ones. Okay. And the radius of the 6 congruent circles can be written in this form, and then we want to find the sum of those values. Okay, so we have a lot of circles going on, so maybe it's good to draw the center points and then connect with intersection of the other circles. And to do so, we kind of start with the label and their centers, so that will be nicer. So if I just connect these guys, since this is the center of like the smallest circle, and then if I draw the radius, then this radius will be tangent to the line if I draw this tangent line. But if I do the same thing with this, that is also tangent line, which means when you connect to center of these 2 circles, that will be a straight line. So I hope that makes sense. So, and the same like reasoning, if I want to connect this center to this center, and that will be also straight segments. So these guys are also going to be the same. So the reason I'm just doing this because I like to get some figures that we can use it. So that is one of these we can try. And then like if you just do this, it looks okay, but you know, there is a gap right here, which is why it may not be that useful. But if I want to kind of do the same thing with the other guys, like what I'm trying to like see if there's a nice picture, maybe we can connect this to this as well, just to see how that looks like. You know, so since we are told these 6 circles are congruent, right? And then if you connect the center of this circle to the center of this circle and the center of this circle, so that will be just the straight line, which will go through the diameter of the largest circle as well. And also, since we have the 6 congruent circles around this guy, somehow like placed, then the angle in between this right here or this right here is going to be 1/6 of the 360, which is just the 6 degrees. So that is something useful because 36 to 90 is always helpful. And also we just need to label that this was a 1 unit. So let me write those. So the radius of this is 1, and then this is, I'm gonna call this is R, this is R, and then this is R, this is R, this is R, this is R, this is 1. And if I connect these, this radius as well, so this is also R. So from this tangency point to this center point, that whole distance is 4 units. So if this is R, then the remaining part right here, so if I'm gonna label this is A, this is B, and maybe this is C. So the AB has to be 4 minus R. So now we have a triangle right here. Now this is R plus 1, this is 2R, and then this is 4 minus R. So we can just kind of drop 90 degrees like this, so we can get a 36 to 90 and go from there. And then that will, like with the Pythagorean, that should be good, I guess. But we can try that for sure, but I'm gonna use log cosine instead. So like, because I have the 3 sides of this triangle and then 1 angle in between. So if I just remember the log cosine, so it looks like it's a square of one side equals like the sum of the squares of the other 2 sides minus 2 times the product of those other sides times cosine of the angle that is opposite to side A. Okay, so in this case, I'm going to take this guy as my side that is alone, so that's 2R. So the 2R squared equals B squared. So I'm going to take this as R plus 1 to the second power. And then this is AB, which is going to be 4 minus R squared minus 2 times B and C, which is R plus 1. And then 4 minus R times cosine 60 degrees. So like if you don't remember the cosine 60, then you can always use the 30, 60, 90 triangle. So which is going to be useful. So let's say this is a 30, 60, 90 degree. So let's assume this is 60, this is 90. So that should be root 3, and this is 1, this is 2. And then cosine 60 is the adjacent divided by hypotenuse, which is 1 over 2. So then I will just replace that now. That's going to be the case. So if I just eliminate these squares, I will get 4R squared equals the R squared plus 2R plus 1, just as square a binomial. And then this is going to be 16 minus 8R plus R squared. And then since this is 1/2 and then this is 2, 1/2 and 2 will be canceling each other. So you will get minus of the product of these two. Let's multiply this in parentheses. 4R minus R squared plus 4 minus R. And I'm going to clean a bit. So we have R squared. Let's actually do this first. 4R squared equals this R squared will be 2R squared. And then 2 minus 8 is negative 6R. 16 plus 1 is 17. And then if I expand this negative sign, so you will get 4R plus R squared minus 4 plus R. So now 2R squared plus 1R squared, that's 3R squared. If you subtract from both sides, you get just R squared on the left. Okay, and then we have 1R, negative 4R, and then negative 6R. That's going to be negative 10, negative 9R. So that should be negative 9R. And then 17 minus 4 is just the constant term, which is 13. So I hope that was clear so far. So let's clean this now on one side. So the R squared plus 9R minus 13 is equal to 0. So, you know, the solution gonna be our, like the radius of the circle that we are looking, which is gonna be in this form, which is a good indicator. We have to use the like quadratic formula. So let's use that. So that should give us negative 9 plus 4 minus, like B squared will be 81 in that case, minus 4 times A, like A, the coefficient of this, which is 1, and then C is negative 13. And then this is all over divided by 2 times A, which is 2. Since we know the radius has to be positive, so we should take the positive version of this guy. So we will get negative 9 plus, that will be for the like positive 52. So if you add that, so you will get 133. And this is divided by 2. So since, you know, the 133 is a number that we cannot simplify more, so we have to leave as it is, like, because also there is no number in front, so which is a good indicator that we don't have to try anything, to be honest. And then we just want to add these guys, so that should give us like negative 9, 133, and 2, which is 126. So like the question itself wasn't too bad, to be honest, but like it's not easier to see immediately this angle. So that was the, I guess, one of the challenges. And then maybe using log cosine is not the first option for some people, but you can try like dropping the altitude from here, and then you get 30, 60, 90. So based on that, so you can find the legs of the triangle, and then you got another triangle right here. So you can just go from there as well. But that is at least one solution. So I hope that was clear. I'll see you in the next video.